Year 9 and welcome to our new topic of energy. In this first lesson we're going to be talking about the different types of energy stores that we come across in science. So the first thing I want us to think about is what is energy, because energy is one of these terms which we throw around on a day-to-day basis. So to begin with, we can start thinking about what energy is not. So energy is not a thing you can find or touch. It's not a substance that you can hold. Energy doesn't explain why things happen. We tend to use forces to explain why things have happened. So energy doesn't do that either. So when we are talking about energy, we're using it in a mathematical sense to calculate potentially how far, fast or high or hot something might get. We can quantify what an object is doing or what it is capable of doing. So this word quantifying might be unfamiliar to us. We might have come across the term quantity before, like a quantity of something. So quantity is another word for talking about numerical stuff. So when we're talking about quantifying something, we're talking about putting numbers. So when we are dealing with numbers in science, we always use units. So our units of energy are joules, or if we've got 1,000 joules, then it becomes easier for us to use kilojoules. So we can use our calculations to look at how much energy is stored, and we'll look more at this next lesson, transferred between the different stores in a system. So we need to be careful here about defining what we mean by systems, because we have different types of systems. So these are examples of simple systems. So in the top left, we've got a Newton's cradle. So this, you pull one of the balls back and let it go forward, and it sends the other balls knocking into each other, and it works back and forth in a pendulum motion. And then everyday object I'm sure you're all familiar with in the bottom right is a kettle. So these are both examples of simple systems where we can consider the energy stores involved here, and next lesson when we look at transfers we can also talk about those. But in the real world we have lots of systems that are interacting with each other. So this is showing quite complex systems where you've got lots of stores and lots of transfers happening. So the way in which we define what a system is that it's an object or group of interacting objects which store energy. And the particular type of system that we look at is called a closed system. And so this means that we don't have any energy going in or out of the system. So it's closed, not open for business, nothing coming in, nothing coming out. So one of the things you might be asking yourself is why we actually calculate energy in the first place. Why would we want to? Why would we bother? So one example, again linked to your day-to-day life, we talk about charging our phones every day so that we have enough battery to last us through the day. So we have energy, and we'll talk about the type of store that our phone has. And we transfer that energy when we use it. So making a phone call is just one example of how we transfer the energy stored in our phone. So if we can calculate the amount of energy that would be needed for a 1-minute phone call, we can then work out how long we can talk for before the battery needs to be recharged. So when you're considering buying a new mobile phone, you might look at the technical specs. And that's one of the things that you might compare, is how long that phone lasts whilst you are actually using it. So what we have here is a system set up. I'll play it one more time. And of course you are free to pause and rewind this video as you choose. But I want you to be considering what different types of energy stores might be shown in this setup. So that final time, but of course go back, revisit, rewatch. Write down what energy stores you think there are in this diagram. Okay, I'm gonna ask you to pause the video while you complete this. Okay, so we've said there are 8 energy stores. So these are the 8 energy stores that we talk about in physics. And we'll talk about what each of them are in a moment. So magnetic, nuclear, elastic, electrostatic, kinetic, gravitational, chemical and thermal. So if we jump back to our animation and we think about what steps were happening here, we have elastic potential with our spring being stretched. We have our thermal store of the candle. And we have this gravitational potential of the ball, which then falls down when the fire causes the string to break. So one task for you to do now, and so if you pause the video after my explanation to give you time in order to do this. So on your worksheet you have got these diagrams here, but on the back of your worksheet you may not actually find these diagrams particularly helpful to remember these. So instead, come up with your own pictures for these different energy stores. So on the back of your worksheet, draw your own pictures as prompts for these different energy stores. One way to help you remember these stores is coming up with mnemonics. So this is a way in which you can help learn the order of those stores. Now, you don't need to learn the order, however, you do need to know all 8 of those, and a mnemonic can be a nice way to make sure that you cover all 8 of those. So one example here is many nasty evil elephants kick giant cuddly toys. And you'll notice here, again, we can supplement that with an image that's going to help us remember that mnemonic. An alternative one is 8 kilograms of cement. And here we've got the kg and the cement, which are those starting letters for our different stores. So we're going to start talking about each of the different stores in turn now. So the first one is our gravitational potential energy. So this is the store as a result of something being raised above the ground. So we have 2 balls here that have been raised at different heights above the ground, and we can see the impact that they have when they go to fall to the ground. So that is because the ball that was raised higher up, that had a higher potential energy than the one that was lower. Our next one is our example of our elastic potential energy, which we said before when we looked at that animation, that it can be stored in objects such as a spring. A bouncy ball is also an example, but it's also stored when we stretch things, so things like elastic bands. That's where that name comes from. I'm sure if you've ever flung a hairband or an elastic band before, then you will know the further you pull it back, the further it will go, and that's due to the higher amount of energy that gets stored as you pull it back. Similarly with a spring, if you compress it as much as you can, it's going to spring a lot further compared to if you only compressed it a little. Kinetic energy then is stored by an object which moves. So the faster the object is moving, the more kinetic energy is stored by that object. We can also talk about energy that's stored within objects. So we talk about the internal thermal energy of particles. So the higher the temperature, the higher the amount of thermal energy that is stored by those particles in an object. And jumping across to our other science, chemistry, chemical energy, which is stored in batteries, that is due to the chemicals that are stored inside it. this is something that triple chemistry students will learn more about in year 10 or 11. So the larger the battery, the more chemicals it has in it, and therefore it is a larger store of chemical energy. And then our final three are quite similar, particularly our magnetic and our electrostatic. So magnets, I'm sure you're familiar with. They attract or repel each other. And we've seen that as well with charges this year when we looked at ions, where there was charged particles. So with our magnets, we have attraction between the opposite poles. With our ions, we're going to have attraction between the oppositely charged ions. And that attraction or repulsion, that stores energy. So it's energy stored as a result of charges or magnets being pulled apart or pushed close together, playing on that attraction and repulsion properties of the magnets or the charges. And then finally, the nuclei of atoms, they are a store of nuclear energy. And you might have heard about nuclear energy as we try and harness that through nuclear power plants as a cleaner alternative to fossil fuels. And that's taking the use of the energy that's stored in the nuclei of particles, of atoms. So your next activity is to decide what you are going to have to do to increase the energy in each of the following stores. So on your worksheet, decide you're going to have to change to increase the energy in each of those stores: the kinetic, the gravitational, the elastic, and the thermal. And if you pause the video, okay, so you're going to go through the answers now. So with our kinetic, if we move it faster, we increase the kinetic store. Gravitational, we saw that if we move it higher, we increase its gravitational potential. Elastic, if we squash it or stretch it, then we're going to increase the elastic potential rather than just leaving it untouched. And then for our thermal, if we increase its temperature, we increase the thermal store. Okay, so the next section of this video is going to be a bit of a quiz, thinking about what energy stores each of the objects have. So first one, pause the video while you have a think. And this is elastic, because we are stretching the spring. Next one, again, pause the video while you have a think. And this is gravitational potential, because that water is being stored at a level above the ground. Next one, again, pause the video so you can have time to think. So there are actually two going on here. One you'll probably have guessed straight away because I've told you what it is. So ring magnets, we've got some magnetic potential going on there, but also because some of them are above ground, we also have gravitational potential that's being filled. Next one, again, pause the video so you have time to think. So with charcoal, we use this for fires and we light it, but charcoal itself is a form of carbon. So when we're doing this, we're releasing that chemical energy in a chemical reaction, combustion reaction, converting it into carbon dioxide, gas and water vapour. Next one for you, identify which of the energy stores are filled. So that bow there, slightly pulled back. Again, pause the video so you have time to think. And this is elastic because we're stretching the bow. So this is our next one. Again, pause the video so you have time to think. And this is our gravitational potential because we're talking about water that is being above ground height. Next one for us, so similar to the charcoal one, pause the video so you have time to think. And of course, this is a chemical energy store. Again, we release that energy through chemical reactions. This one, so showing something that is red hot, have a think about which store that might be indicating. And so this is our thermal because we're talking about increasing the temperature of something. Okay, next one, tennis racket and ball. Pause the video to have a longer think. And this is elastic, both in the ball and the racket. So the ball will get slightly compressed, but you can see the face of the racket is being stretched backwards. And so again, it's being stretched and therefore it's elastic. This one, traveller at the top of a mountain. Pause the video to have a think. And this is our gravitational potential because standing above the ground. This is our penultimate one, so pan of boiling water. Pause the video to have a think. And this is thermal energy because we're talking about something that's hot, so we're talking about it having a high temperature. And then finally, this is supposed to be a moving car. Obviously, it's a picture, and therefore we can't see that movement, but we are assuming that car is moving. And so because we're talking about moving, we are talking about our kinetic energy. So your next activity on your worksheet, you have a table which looks exactly like this. And so what I'd like you to do is identify what the 8 energy stores are and give an example, thinking about all those examples we've just looked at in this video. So I'm gonna move on to our plenary quiz in this video, but do pause the video to give yourself time to fill this in. Before we go into the plenary quiz, let's whiz through the answers to these. So an object speeding up or slowing down. This is going to be our kinetic energy store as we're talking about a moving object. And an example of that could be a car, but of course specifying this is a moving car, not a stationary car. An object which is altering its height above a planet. This is our gravitational. An example of that we looked at was a rock on a cliff. When reactants combine or separate to give products. So here we're talking about chemical reactions. And so we're looking at harnessing that chemical energy store. Example could be charcoal, it could be a battery, it could be wood. An object warming up or cooling down. So when we're talking about the temperature of objects, we're talking about thermal energy. Example of this, we saw that saucepan of boiling water. You might have other examples for these, and that's absolutely fine. We've gone through lots of them in this video. Object being stretched or squeezed. This is our elastic, such as our bow from a bow and arrow. But of course it's only the bow part that's being stretched there, so that's the only part of that system which has the elastic energy. Magnets being pulled apart or allowed to come closer together. So of course this is our magnetic store. Example we can talk about here is of course magnets, but I'm going to give a more real world example, which is the maglev trains, and they use magnetic energy in order to help those trains move. Electric charges, this is our electrostatic. And here we can talk about static electricity, where we saw that balloon being stuck to the girl's hair. Nuclear particles are rearranged, so this of course is our nuclear. And then an example of us using this, I talked about nuclear energy. So final quiz are 8 ways to store energy. So 1 to 8, pause the video, have a go. And now I'm going to whiz through the answers in order. So gravitational, this is our energy stored in raised objects. Elastic, energy stored in stretched or squashed objects. Kinetic, our energy stored in moving objects. Thermal, energy stored in hot objects. Chemical, our energy stored in fuels, food and batteries. Magnetic, energy stored by magnets, so we talked about them being moved apart or pushed together. Electrostatic, energy in static electric charges that are not moving. So that's the crucial part of that, they are not moving. And then our nuclear is our energy stored in the nuclei of atoms. Thank you all for watching. I hope it was useful. As always, please do email me or message me on Teams with any questions you might have. I am still here to support you.